Okay, so hi everyone. Nice to see you all. Welcome to this webinar. It's called Opportunities for Easier and Faster Use of LiDAR Data Through Digitalization. It is a joint IEA Wind Task 43 and Task 52 webinar. My name is Sarah Barber. I lead IEA Wind Task 43. And I'll be sort of talking you through the webinar today. If anyone wants to turn their camera on and smile, it's always nice to talk to smiling faces rather than blank screens, but it's fine if you can't. I think if you've got any questions while we're talking, just write in the chat. And we'll have time for questions where you can turn your microphone on as well at some point. So the general plan is that I just tell you a little bit about IEA Wind Task 43 and 52. I'm going to show you the survey results. When you registered, you asked answered some questions. I'm just going to show you what the results were, and then I'm going to do a short Mentimeter with a few more questions to get yourself psychologically prepared to answer a few Mentimeter questions. Then after that, we're going to have Andy Clifton from Enelace, who's here, to talk about IEA Wind Task 43 and the opportunities for digitalization and LiDARs that they have discovered in their work. And then Stephen Holleran from Brightwind is going to talk about the wind resource assessment data model. And then finally, Yuri Marakovsky from OST, which is also the university where I work, is going to talk about an introduction to ontologies and their potential uses with LiDAR. And hopefully we'll have a little bit of time for questions at the end. So is everybody happy with that plan? Anyone got any fundamental questions or difficulties or things that I've forgotten to say before I get started? There is a bit of background noise from someone. Is it Stephen? Maybe, yeah. Okay, so in case you haven't heard of IEA Wind TCP before, it's an international cooperation of 24 countries and sponsor members that share information and research activities to advance wind energy deployment. The point is to align research and development across countries, but also across continents. So sometimes you have, EU projects running, and then you have some US-based project running, or some China-based project running, and then maybe they're not aligned. So the idea is to create some sort of mutual benefit from sharing and aligning and working together. And there's a load of different so-called tasks on lots of different topics, which are shown here on the right. And anyone can start a task as long as there's interest from lots of different organizations globally to come together and benefit somehow from joining forces. So you can see all the different types of task we have. The task that I lead and who planned this webinar is called Task 43, and it's on digitalization. And so we're trying to act as a digitalization catalyst by driving open collaboration. And the general idea is to deliver either insights, so that was going to be some sort of papers, or webinars or discussions, recommendations. We develop these things called recommended best practices or recommended practices, and then also standards and tools. So we develop, Yuri will tell you about the ontologies, for example, or we've developed the wind resource assessment data model. And the areas that we focus on are data, culture, and co-opetition, which I'll talk about in a second. Just as a quick heads up, what digitalization is, it's kind of a weird word. It's not digitization, but it's digitalization. Apparently, it's a megatrend, one of the 5 megatrends in wind energy technology, according to ETIP Wind. We define it as the organizational and industry-wide use of data and digital technologies to improve efficiency, create insights, and develop products and services. So the idea really is to actually just create value from data. Instead of having a load of data and not knowing what to do with it, not using it in the most efficient way, we're trying to develop some sort of tools or solutions for a more efficient use of data so that more value can be created from it. And so what we do in Task 43 is we base our work on this very nice paper, which Andy actually led, called The Grand Challenges in the Digitalisation of Wind Energy, where we did a lot of interviews and surveys and literature reviews and thinking about how we could advance digitalisation in wind energy. And we came to this conclusion that there are these three areas of importance. So one of them is data, so creating data structures to make the use of data more efficient, which is kind of the topic today. But then we also came to the conclusion that organizational culture and co-petition, which means competition and cooperation, so kind of working with or against each other in a kind of way, challenge or some sort of innovative collaboration to try to bring the industry further on. So the three areas that we look at. And this picture just really shows we have these three working groups who look at these three topics, and then we also try to feed the results into some use case deep dives. We try to disseminate and coordinate everything we do and interact with the industry. And one of the reasons for having this webinar is to get people who have been working who work with lidar connected to what we're doing. So a type of output that we develop is the Wind Resource Assessment Data Model, or an ontology publishing portal, Technoportal, a couple of best practices here that we've recently written, or a data maturity roadmap, for example, a review paper about knowledge engineering and wind energy, and things like that. Task 52, I'm sure Andy will tell you more in a minute as well, but the general idea is to make wind lidar the best and preferred wind measurement tool for wind energy applications. And they have these four different themes. So looking at universal inflow characterization, replacing met masts, connecting wind lidar, and then accelerating offshore wind deployment. And yeah, so let's get to this webinar. So the idea is that the more lidar measurements we make, we're having increasingly large and complex data sets. Therefore, we have growing challenges in efficiently processing and applying this data to real-world projects. And so what we want to do today is explore opportunities for easier and faster use of lidar data through digitalisation. And we also want to look at how standardised formats, data models, and ontologies can reduce data wrangling time and effort. So getting to the survey, yeah, there were 50 people took part, 60% from industry, 24% from university or research, and I guess 16% probably individual, unaffiliated people, I guess. So the first question we asked was, how frequently do you work with lidar data? So we have some people who are not involved directly. We have quite a range. Most people are involved from never to every day. And then we asked, what do you use lidar for? So we have kind of an equal proportion of prospecting, planning, and research, but we also have a reasonable number of people optimizing operations and doing investment decisions. Only 14% use open lidar data. The main challenges with the data, so the top three are lack of quality, lack of quantity, and interoperability problems, along with some others which were also rated quite highly as well. I'll share the slides with you afterwards as well, so you can look at that in more detail. And then the first priority, maybe it wasn't the best question to ask, because the first priority is not really clear. I guess the most number of people answered improving quality, but there was quite a distribution of the other answers. So what I want to do is now ask you all to fill in this Mentimeter, take part in this Mentimeter if you feel like it. So I think the easiest way to do that is just quickly take get your phone, or you can go to menti.com and put this number in. And I've got a few general questions, and I've got some questions about these challenges which you reported in the registration form, and then I've got something about opportunities. So I think if I actually display I can get the QR code still. If I do the presentation, I think the QR code comes, and I can do both at the same time. So the first question is, do you have time to do your job? Um, I guess the people who've come here have got time to come to this webinar, so they might be answering more positively than other people. So, anyone else want to take part? We have 12 people participating, a few more coming in now. So most people are on usually. Well, no, not most people, half the people. Okay, very nice. Oh, nobody's on always. So the next question is, are you using digitalization in your job already? No, very little, sometimes a lot. I'm assuming you can now see this next question. Yes, that's coming in. So most people have lots. I saw some questions here. Sorry, Ian, I can maybe when one of the other people's talking, I can look at the data in a bit more detail from the registered participants and tell you that. Okay, so most people say lots. Is digitalization helping you now? I mean, in general in life? I mean, in general in your job? Sometimes. Lots. Okay. The general consensus is yes. Anyone else want to answer that question? Okay, I'll move on to the next one. Can't have a questionnaire without asking about AI these days. Are you already using AI in your job? So we've got quite a few lots, sometimes very little. Obviously, it's depending a little bit about on what sort of job you have, but so the main consensus is yes, I would say there. And then, do you think AI will help you in the future? So a very strong consensus of lots there. Okay, very good. And then I've got the three questions about the top three challenges that were mentioned. I'm hoping that the people who are present now are representative of the representative of the people who answered the survey. So I'm going to ask first about data quality. So we're talking about lidar data, right? So if what are the main causes of a lack of data quality in lidars for you? Is it sort of environmental issues, problems with the instruments, problems with signal processing or post-processing, citing the lidars, managing the data, or something completely different, which I didn't put on here? If anyone's put other, they want to write the other in the chat, that would be interesting to hear. We have quite a lot of instruments. So if anyone wants to be more specific on some of those answers, please write in the chat. And then the next question is about availability. That was the second, one of the, I can't remember, that was one of the top three. So is data not available because people don't want to share it, because there's no place to share it, because it's just expensive and difficult to carry out measurements, because there's some sort of legal barriers to making data available, or people don't know how to prepare data and therefore don't make it available, or other. Okay, so we have quite. Yeah, Andy, you said about availability, about how much of the data are usable. I realized that when thinking about what things to write at the bottom here, I realized there was kind of two main ways of understanding what availability means, and we didn't specify in the question. So it could mean, yes, the amount of data that's available compared to how much you had in the first place. It might mean that. So I think we'd have to look into that a little bit more to understand. If anyone wants to write any comments on that, please do as well. And then the third thing about interoperability. So what are the main causes of the lack of interoperability, do you think? Is it the different vocabularies describing the data? Is it the lack of consistent metadata? Is it different data formats or different data structures? If you've written other, please, I'd be really interested on this one actually, what the other might be. So different data structures is winning at the moment, by quite a lot. Okay, and then I think a final question, because we're kind of gone 3 minutes over the planned time for my part. What opportunities do you see for easier and faster use of lidar data? And I've kind of split it into these three areas. So it's not going into detail, but is it more in the area of automation and remote management, fleet level learning and predictive maintenance, or fair data and standardized schemas, or something else? So fair data and standardized schema is quite high. Fleet level learning, predictive maintenance. Okay, great. I will then use this opportunity, I think. Let me just check with my presentation that I didn't plan something else. Yeah, so I wanted to transition from that question because Andy's now going to talk about opportunities. So, Andy, if you want to get yourself ready, and if anyone's got any important questions, maybe short questions while Andy's just getting himself ready, feel free to speak or write in the chat. You want to take over, Andy?
Sorry, just having the usual fight with Teams. Brilliant. Awesome. Thank you, Sarah. I'm ready to go unless there are any questions you want to address.
Doesn't seem so.
Right. Okay, well, thank you. Can you all see my screen? Well, can somebody see my screen?
Perfectly, yes.
Good. Thank you. So Sarah invited me to talk a little bit about what's going on in Task 52. So my name is Andy Clifton, and I run a business called Enelace doing data monitoring for LiDAR and MetMass and other systems. I also lead the digitalisation working group in Task 52, which is the task about large-scale deployment of wind LiDAR. And Sarah already gave a short introduction to Task 52, which is brilliant. So thank you very much for that. Task 52 is focused on wind LiDAR. So Ian Curry, you mentioned that you'd had strong pushback from wind turbine OEMs about the use of wind LiDAR data. It might be interesting for you to have a chat with us in Task 52 about what's going on there and see some of the other initiatives that are happening. Task 52 is basically asking a question, which is the use of wind LiDAR is growing dramatically and rapidly across the wind energy industry, and not just in Europe, internationally. And so what we've done is we've said, what happens when wind LiDAR starts to be the preferred tool for wind measurements? Because at the moment, let's face it, masts probably dominate still out there. And we asked, what happens to the industry as a whole, and what needs to change for wind LiDAR to be the dominant measurement technology? It's an international task. There are I think over a dozen countries that participate in that. And if you'd like to know more about it, there is a URL there. And you can also get in contact with Julia Gottschall, who's the operating agent at Fraunhofer IWIS in Germany. What I'm going to do very quickly is just acknowledge the group of people that have worked with me on this. There's Mark Carverley from the UK, Julia Gottschall in Germany, John Medley in the UK, David Schlipf in Germany, and Preethi, who's also in the UK. And this was a team representing everybody from wind lidar OEMs through to site developers, site operators. And we've been operating for a couple of years through the task. The other thing you will notice is what made this possible, and part of the reason why I asked about how people, or asked Sarah to ask about how people were using AI, is these slides have almost entirely been generated by Claude using a document that we prepared internally. And this was also a test case for me about how digitalization could help me in my LiDAR related work. So as I mentioned, we've chosen a scenario which is rapid growth in LiDAR, and you can sort of see, everything works at the moment, but to really stress test everything, we said, well, what happens if you have 10 times the amount of LiDAR? And it's maybe a bit out there, but the growth rates on the use of wind LiDAR are such that companies are abandoning metmasts left, right, and center. And we really are seeing companies switching from having nothing to having an entire fleet based on wind LiDAR. And so we said, what would happen if every measurement was made using wind LiDAR and you had 10 times as many wind LiDAR out there as you do at the moment? And that lets us break a few things, which gives you a really good test case for digitalization. And what we quickly realized is, even though Task 43 and Task 52, initially we concentrated on the idea of data exchange and different data formats, we realized that data is actually only one part of the problem. You have to design and manufacture your LiDAR in the first place, and you have to be able to design and manufacture 10 times as many. You have to be able to sell 10 times as many. You have to be able to train 10 times as many users. You're dealing with 10 times as many sites in operation, and so on. And it goes all the way through evaluation, acceptance, it goes into maintenance and support. And what we realized is that in every single one of these cases, anywhere where there is a person in the loop, those people become the critical issue, and you have to look at ways to replace people, and you have to have tools that allow you to do it. So if we dig in a little bit further, just some of the things that we saw, for example, production. Obviously, if you're going to have 10 times as many LiDAR, you need to produce 10 times as many LiDAR systems. And currently that would mean adding more people onto the production lines, but obviously that's not feasible because those experts don't exist. So you have to ask yourself, can we automate? Can we put robots in here? Or can we build LiDAR that are simpler to build? Same goes for training, same goes for maintenance. And I'm not going to go into each one of these, but I will, Sarah, I think we'll be making the slides available afterwards, so you're welcome to have a look at it. It comes in the measurement and data as well. So if you're in Germany, one of the things that you have to do with your LiDAR is you have to send it off to one of 3 or 4 different verification facilities. And it's a very important step currently to test the capability of, but is it possible to remove that verification step? Because that verification step becomes a bottleneck. There simply are not enough facilities and there are not enough people to check the data coming out of verification. That's just an example of what happens with the measurement side.
Did
You've
you
got to
purposely
monitor.
sorry to interrupt, did you just purposely stop sharing your screen? Because it stopped for me anyway.
No, my connection just glitched, I think. Was that on my end or your end?
I don't know. Does anyone else see the screen?
Nope.
Oh well, all right, thanks for that.
Going from
We
me as well.
are actually having a pretty good thunderstorm up here, so it could be that we just took a hit somewhere in the system. Can you see my screen again now?
Yeah.
All right, thank you. Good. Did you see any of these slides before? Where did it stop?
Yeah, we saw them. It stopped
right.
just like 5 seconds before I said something.
Smashing. Okay. Let's see, where were we? Data management, all of that stuff in there around data. And this is where I'm really curious to hear the rest of the presentations here. The data throughput does become a challenge when you have a lot of LiDAR. And then let's see. There's also the fleet aspect of it. It's not just design and build or deal with data, it's the operation of the fleet. So you now have 10 times as many LiDAR that you need to move around, that you need to keep an eye on, that you need to install, that you need to check or interface to your systems. And And at this point, data security becomes obviously a very big issue because you have a lot of data potentially moving around automatically that needs to be checked. And so this was the nice thing about taking a 10 times as many approach as opposed to a sort of 50% more this year or gradual growth. You don't break anything when you just keep on gradually growing. You have the opportunity to tweak, and you don't necessarily see where the failure points are. It also gives you a couple of different opportunities, right? One is that you can scale. The first one is that you can do that if you apply digitalization and you apply automation opportunities, you can grow your business, you can support many more lidar without having to scale your people. So obviously that impacts your bottom line. That can make you more profitable. Interestingly, the question that was asked about the opportunities, fleet level management came up and fleet level learning came up as the second opportunity in that. And it's one thing that we identified is once you have a big fleet and you have a lot of data moving around and you have a lot of digitalization, you can actually start learning off of that fleet. Where can I reliably get data from lidar? What kind of weather conditions or sites might give me challenges? Where might it make sense to still have a metmast, pair that with a lidar to get good data availability? And then there are also things like bringing in fair data thoughts so that you can get better and more data and start learning from each other. What we did realize when we looked at this is that a lot of these kind of thoughts and a lot of these solutions are already out there. There are a lot of things that have been doing, say, in telecoms or IoT, where a lot of these thoughts, a lot of these concepts have already been looked at and they're quite ripe. And there are some ideas that rather than us developing everything new in the wind energy business or for wind lidar specifically, we can pull across a lot of those ideas from other sectors and sort of wrap them with wind lidar language and understanding and apply them to wind lidar. And so that's things like how do you measure, or sorry, how do you monitor your large fleets? How do you deal with lots of data? How do you make sure the right people are seeing stuff? How do you make sure that you understand what's happened to your data, your equipment in the first place? So we also had a look at why these things are not necessarily coming into everyday use. And the interesting thing that we found was in the wind business, we're dealing with 20-year plus project life cycles. So the people that benefit from digitalization, from better access to data, are not necessarily the same people that have to pay in the first place to implement the digitalization. It's potentially the owner operator in the out years that benefits from the efforts that are being made by the OEM or the site developer or the people that are doing the resource assessment. And if that value isn't aligned and if there isn't a way to add value and basically pay for it at different handover points in the project, who's actually going to implement these things? So what we realized is it was probably going to be very useful to actually work on the business cases and document those business cases. So if people have been benefiting from digitalization and have been benefiting from being part of a digitalized data pipeline, if you like, or from a digitalized manufacturing or training pipeline or support pipeline or operations pipeline, is really helpful if you actually are willing to stand up and share that experience and share that, because that's one of the biggest levers that we actually have for acceptance, is seeing that yes, it works and it can be done and it's effective. So with that in mind, just to finish off, a mature lidar ecosystem looks like you know from end to end what's happened with your data and with your equipment. There's standardized data, so it's easy to move things through that pipeline. You've got an open interface. Things are vendor neutral. It doesn't matter whether you bought a system or got your advice or you're monitoring from company X, Y, or Z. Everything is exchangeable. And ultimately, what it means is that experts, like a lot of the folks in this call, you are focused on being experts. You are not focused on being data wranglers, right? And that's one of the biggest opportunities that we see. So with that, I would like to say thank you very much to Claude for doing my presentation for me. The rest of the folks in the team who helped me pull this together, and there is going to be a report coming out about this in the next couple of months. we're just going through a review process because we want to make sure that everything's right. I think at that point, Sarah, how do you want to handle questions and comments and?
I think if there's a short question or with a short answer that we can do them now, and otherwise I would wait till the end so that everyone gets a chance to speak. Is there anything very important to ask Andy before you forget and we move on to a different topic, or should we? Otherwise, we'll just continue. Anyone?
Awesome.
Okay, so thank
Thanks
you to
very much.
Andy and Claude together. And then Stephen,
Hey
please.
there. Guys, back. You can see it okay?
Yeah.
Yeah, so hi, I'm Stephen Holleran from Brightwind. We're energy yield assessment company. I'm part of Task 43, leading the wind resource assessment group, where we've developed the data model. Wrong screen highlighted. So the data model, just jump straight into it. The wind resource assessment data model is basically vendor neutral, not just an OEM neutral. It's a way to transfer metadata from one organization to another. So it's not just data coming from lidar or logger OEMs. So it describes how a resource measurement campaign, lidar's metmass, is configured. So how the station has been installed and how that configuration changes over time. And that metadata then gives meaning to the time series data. So you get your logger files or lidar files in these columns of data, the time series data, and what does channel 1 actually mean in that time series data. So the data model gives the time series meaning. So the data model covers metmass, lidars, SODARs, floating lidars, ADCPs, wavebuoys, and even solar measurement stations, all in the same model. And it's in use today. I can't remember what version, 1.4 or 1.5, I think we're at. And it's been, version 1, I think, was 2021. So it's out there on GitHub in use today by lots of organizations. So I'm kind of linking this back to your responses, Sarah. You've mentioned 3 of them. I'm picking out some of them, like the lack of metadata, the lack of consistency in the metadata, the lack of consistency in the naming and the structure of the data, and the interoperability problems. All those, I think, are linked back to the metadata that describes the measurement station from a wind resource analyst point of view, someone who's dealing with the 10-minute data going downstream. So I kind of want to demonstrate the usefulness of the data model in terms of the device orientation, specific property. So the device orientation, so the LiDAR measures the wind speed relative to its own body. So the LiDAR is installed physically on the ground and it's orientated a certain direction. It may not always be orientated north for whatever reason. So there's the physical orientation, and then there's the orientation that's typed into the device itself. And the orientation that's typed into the device itself is to account for the offset from north. So the wind direction that's given out in the device time series files are supposed to be wind directions relative to north. So you got 2 values representing the same thing. They may not always agree. There's several different reasons. The device might have been orientated to a certain direction, but what was typed into the device is different because somebody's typing a number and it can be typed incorrectly. There could be confusion about whether it's relative to magnetic north or true north or grid north. depending on how the device orientation was measured in the first place. So there's several different ways that the device orientation could be different from each other. This can have, might sound simple, but it can have a major impact. And I've got an example here of 30-degree difference. So if there's a 30-degree difference between those two properties, you can have every single wind direction is off by 30 degrees, and it has massive knock-on effects. 30 degrees sounds like a lot, but if you're talking about magnetic declination, you can easily be 30 degrees out in parts of Canada, and the US can be 30 degrees out, and it's just a confusion in what was typed into the device and what it was offset from, what is north. So it can have an impact in the layout. The windrows will be wrong, impacts on the layout, the weight calculations, if you've got sector availability system going on. 30-degree offset can be a silent failure. It might not look that bad. The windrows might not look too far off. Hopefully it will be picked up in correlations with reference data and all this, but it might not be. And it can, if it's discovered late at like lender review, you just don't have to reprocess all the data, losing time, reputational. You would have already gotten planning permission permits for a layout that was incorrect, not efficient for the windrows, the true windrows for the site. And then also, if you're doing CFD flow corrections and you've got a 30-degree difference in the orientation, it messes up all those flow corrections. Not as major. So the data model is a JSON schema to describe how a JSON looks like. And this on the left here is what the JSON looks like, with loads of rows taken out because I'm just focusing on these two properties. You've got the measurement location, you got the vertical profiler properties. So this is the physical orientation relative to true north here. And then in the logger main configuration, you've got a lidar configuration where the logger stated device orientation is typed in. And so these could be easily 30 degrees off. So the data model captures these two values, physically separates them in the data model. You got the physical location and the logger stated location. The mismatch then, once you've got those properties in the data model, is just a quick check from for an analyst, and they don't have to go sifting through PDF reports to actually pull out what the orientation is, what's the physical orientation. The logger stated orientation usually is in the header of all the daily files you get from the device itself, but the physical orientation would be written down in an installation report somewhere, and you have to go search through it. So the first analyst looking at this data is the one that needs to do the validation. And once they've got that happy, then every single downstream analyst or workflow can rely on this and not have to go sifting through all those PDF documents and trying to figure it out. So you've got structured metadata leads to automation. You can have QC code when an analyst is starting to do some work that flags the mismatches. A pipeline can take the JSON and apply the orientation correction automatically. So it knows, it sees the two values, knows that they're different. If there's a correction to be applied to the wind directions, it can make it automatically. The same code, because the data model is structured metadata, you can write the same code, the pipeline once, and it can be applied to all different measurement stations that you come across, as long as they follow the data model structure. And the orientation, this device orientation is just one of many properties that can have a physical and logger split. There's the device datum plane as another, and then there's lots of other metadata that's needed for a wind analyst to do their job. So coming back to the survey you've got, lack of metadata. So from a wind analyst point of view, we've captured the vast majority of the metadata we need from a lidar device to do our job. It's a JSON schema, so it's consistent metadata. The labeling, the structure of the data is all defined in the JSON schema. And once you've got all the data in a standard format, you can reuse the same code. So the interoperability problems minimize. So the data model is there. It captures the facts of a campaign structured form and how it changes over time. It's the foundation for automation and makes scaling possible. So coming back to some of the things you were mentioning, Andy, like on the metadata, the data monitoring, data management, I think you had reporting, all that can be automated once you've got the metadata in a standard format. What it does not yet do is gives those facts in a shared machine readable format, but not across the whole wind energy domain. And that's where we need to go next, is ontologies, which I need to learn more about myself.
Nice transition. I like it.
Yeah.
All right, great. Thank you very much. Does anyone have any short questions for Stephen? Because we've got a quarter of an hour left. So does anyone want to ask him something? I'm not trying to stop people from asking questions. Maybe Yuri, if you can really make sure you stick to 10 minutes max, then we'll definitely have 5 minutes for questions at the end.
I'll try to be quick.
35 slides.
Yeah, but they're not 35 concepts people have to learn. So okay, then let's skip the introduction. We'll go right into it. So as Stephen nicely mentioned, what is next are ontologies. So what are ontologies and why do we need them? I'm not going to tell right away about what are ontologies, not to bore you right away, but why do we need them? And it's kind of focuses on this box that Andy had in the middle. He had the design, he had the operation, and in the middle was the data box. So we're focusing on a data box. And at Task 43, we talk a lot about frictionless data and information access. There is also interoperability and findable, accessible, interoperable, reusable, fair concepts, but basically boil down to the things like, can I find data information? Can I use it? So like a great example of can I find things is Google. We all know it. So if I want to buy like a sofa, I just type it on Google and the Google will know where I'm located, will know what stores are selling sofa, will know that sofa is a product, right? So what happens on the back end is that Google has a label for all things product and assigns the sofa that I want to buy to this category of a product. And all of these labels for the things that Google might be interested to represent, store locations, products, opening hours, everything is stored in this ontology, which we'll talk about what it is later. They don't call it ontology, it's called schema.org, but it is essentially an ontology. And they have defined the thing called product there. And also a nice point going back to what Andy was saying, who is benefited from digitalization in this sense. So here Google definitely benefited, both the Google and all the e-commerce industry. But I was just thinking that's an excellent point. We really have to think about how it goes for lidar. But moving on, what's another, can I like use data, right? Again, Google developed this format called ML Croissant for data scientists, and it helps to search for data, create, load, download, and use it. But what people might not know, that there in the back, what is hiding is an ontology as well. And going up to like even more advanced uses of ontologies, obviously we mentioned several times today, is used for AI applications, and ontologies can provide data and information for the use of for these AI applications in very different ways. It's quite a complicated topic. You should read the thesis that is published, and there is an entire chapter on it. A short illustration from it, but the main idea is that LLM models, they're trained and the data they have is static. So we have to have some way of providing this information as context to our queries, to the tools that are using the data. And I'm not going to go into things like knowledge grounding and retrieval augmented generation, but it's a whole topic. And trust me on the word when I say that ontologies can help with it. So I've been blabbering about ontologies. What are those? They're formal, explicit specification of a shared conceptualization, which is a mouthful. But what we care about is that formal means that these things are machine readable. They're defined in the strict logical rules. Explicit meaning we define everything that we care about in an explicit manner. And an important part here, it's shared. So we all agree that this is the way to represent reality. So like I was saying before, Google said, okay, let's have a label for a thing, for a concept that is called product. And let's say also say that a product can have a model, product model, and we define specifically how these two things are related, how these two concepts are related. Easy way to think about it as a directed labeled graph. So nodes represent concepts, edges, labeled edges, represent the relationship between these two concepts. And this is very flexible way to represent information, to represent data, because of their underlying graph structure. So for example, if you want to add something to do with sensors, we can go to semantic sensor ontology, and then we can add sensors. We can add a wind turbine from our wind energy domain ontology and say, oh, our wind turbine is also a product, right? And we we can not just stop there, we can keep on doing things, and we can do something like to extend to an idea that is called a knowledge graph, which is just an ontology that has some specific instances added to the concepts. And so what Google might not refer to what they have as an ontology, they will refer to it as a knowledge graph. But what we care about, once they have this knowledge graph, you can query it, meaning you can ask questions about the things you're interested in, you can find things, and you can do some inference on it. Just very brief, because I get asked about it many times. There are so many more terms about all of this. So ontology, knowledge graph, another concept that you might hear, taxonomy, schema. We heard the V-array data model is a schema, not to be confused with a database schema, which is a bit different thing. Not to be confused with schemas that is used for validation, which would be JSON schema. Control vocabularies, data models, information model, conceptual models, data format specification. All of these terms are in a way related. There is a significant overlap used in the different contexts. Ontology can be sort of like a general unifying thing, depending on your philosophical position. But all of these concepts are related. And very often when developing one of these, it means developing an ontology. And let's jump from philosophy into a practical example. How do these ontologies and things get used? So this is a practical example for a JSON LD file for ML croissant format specification. I was mentioning before, developed for Google for data sciences, and I will walk you through some of the features of this metadata file and how it is useful for data scientists or for people who just have to deal with data. The format itself is in JSON LD, which stands for JSON for linked data. So it's an extension of a JSON format that Stephen was talking before. And linked data here is actually what it means. It's just linked to ontology terms. So on top, you will hear something like context, which doesn't exist in regular JSON files. And it's just a domain to which we are referring every time when we use different terms. And you can see already here we have our standard things like description for the data, but we can start to add things like, okay, who is a contributor to here? And then there comes the link data. We say the contributor is from schema.org namespace. So the schema.org ontology I was mentioning in the very beginning by Google, and it has a concept of a person, and it has types of relationships that the person should have a given name, a family name, can have a job title, can have identifier. So I can start linking all of this data and including it directly into my metadata, into my context file in a very flexible manner, as I was mentioning before. But it can go even beyond that. We can start with not only describing what the file is about, but also what is inside the file. So, for example, in that specific example, we had Parquet compressed files, and one of the fields in the table was nacelle direction. It was titled NAC DIR, which is not very clear, especially like, let's say, for someone who doesn't maybe speaks English, that they don't right away figure it out. It's in the cell direction, and also will not be very clear for AI. It would take some effort probably to figure it out. But what we do is we explicitly say, oh, inside that file there is a field, there is a column. It's called this. It's described. We have like a certain description of what that field is, and what even more than that, we can start including more things. For example, oh, it has some unit, and the unit is degrees, not radians, and we can link to another ontology, for example, of units of measure ontology, which would have a shared specified space where that definition exists. So we don't have to redefine it every time when we have to provide our metadata. We can package even more contextual information, not necessarily completely aside. For example, in this specific case, we were packaging information for the wind turbine itself within the file, not as a separate data file. So in the JSON itself, we included both the data about the wind turbine and the meaning of the data through the ontology terms. So for example, here we define the term that is rated power, and we link to something called the open energy ontology, where this concept exists and is defined. And as I said, mentioned before, also mentioned in what units we defined it. As I said, we can keep on adding more contextual information. For example, obscure labels. We can say, oh, the turbine status code field has it is defined through numerical values, and then we can explicitly define through like English language what those fields mean. All of this, just to say, all the shared terms are defined just once. So for example, as I was saying, power rating is defined in open energy ontology. It exists, it's managed by open energy ontology. We don't have to redefine these things. The units of measure are defined in units of measure ontology, and we don't have to redefine all of these things. In the end, what it provides is that when people are using this kind of data, they can quickly generate tables like the one on the top left, where we can, oh, what are the columns in our in a data file? What is a description? What is a data type? What is units that is being used? Also with the link to a specific term defined in the unit domain ontology. Or we can combine the information that we have and generate tables like I have here in the bottom, where I don't have any more in my turbine status. It's not just a numeric value, but also I have status text, so that's clear for humans that are reading through what it is. This is all well, and it allows us to when we can define all of these things. Unfortunately, in wind energy domain right now, there is not that many ontologies that we can refer to or we can use in this kind of context. And that is why we are working right now on wind energy domain ontology, which is like a broad ontology that is going to connect the top level ones, for example, like schema work I mentioned before, basic formal information modeling framework, with some application cases. For example, use of LiDAR data, or LiDAR data would be, or measurements would be one of the use case, so application level. Is there an wind energy LiDAR ontology? Yes. It was actually developed with Andy and Francisco Costa and others. There is a publication, you should check it out. Published on Technoportal. There's still room for improvement. And the way I see it, that this improvement should be use case driven. So we should, the community should select what they're interested in primarily. For example, is the primary interest in data annotation for metadata files, or do you want something that will help with app development, or do you need something that provides semantic alignment, for example, for use with AI clients? We made to help people to go through this task of like ontology development. We also developed recommended practice. Check it out. It will help to like set the mind and see how these ontologies can be developed so that people are successful. With that, I will close by. I don't know if probably a bit more than 10 minutes, but any questions? I would be.
We've got 1 minute. We've got 1 minute left. So well done. All right, thanks everyone. I started to put the links in the chat that Yuri was mentioning, and Stephen's put something in the chat as well. Yeah, we've kind of run out of time for questions, unfortunately. Does anybody have any? So some of the people maybe who are here who have challenges with LiDAR data, does anyone feel like giving us an insight into what their main challenge is? Is it related to this topic we talked about today, or is it completely related to something else? Anyone want to share or say anything? Probably everyone is moving on to the next meeting. So no, I didn't see anyone. Everyone's got to move on. So yeah, I mean, check out the stuff we're doing on the data model and on ontologies. If you want to get involved, come along. If you want to meet us, by the way, you can come to our lovely yearly meeting on the 24th to 26th of June. And yeah, we'd be really interested to get any feedback. I know we ran out of time now, but if anyone's got any questions or comments about what we talked about, if you think it's useful or not useful, or what you think about it, please feel free to write to me, and I'll pass it on to the speakers. So yeah, I guess it's 5 o'clock, so we better close. Do Andy or Stephen or Yuri want to say any last sentence to close?
Thanks for having us.
Really, yeah, thanks. We must have done a good job if there's no questions.
Yeah, must have explained.
I'll take it that way anyway.